these printing laboratories. The important thing, if you remember the Silicon Valley, how it started in garage, and why it took so much time for the beginning when all the technology is developed, and then suddenly they have this huge jump. It's like in late 80s, suddenly there was like singularity jump in technologies. Maybe you remember the reason why it happened and how it happened. I can tell you my ideas about the Silicon Valley and the beginning of these computer technologies, because computer technologies and kybernetics started from, I don't know, from 30s, from 20s even. The first ideas, it was just on paper, it was just ideas, and then it went a little bit slowly, it went to some kind of very primitive, huge, enormous computers, and then later it went to the personal computers, and then it became like everyday use device. And it started in the 80s. If you read something about Steve Jobs and about the founding fathers of the Silicon Valley, then there was a lot of geeks in Silicon Valley, and they had a lot of fun with computers, but they never shared these ideas with like regular people. And like as you say, you can come to our lab, we can teach you, and you will try. But most of the people, they need service. They need simplicity. They need just press the button and everything happens. And I very much doubt that those printers and those 3D milling machines, they are in such level that just like the housewife can come and just press the button and things happening. And suddenly Steve Jobs was one of the first guys who thought about like how to make it just functional. You don't need any back knowledge just to make this device working. And he was, I'm sorry that I'm wasting your time, maybe you thinking more, talking about these 3D things, but recently I read about this subject and I remember this idea, and then when you were just talking, it reminded me that time in Silicon Valley, when there was one guy who was, okay, he was geek, but he was not such geek as Steve, how was the other guy, Steve Wozniak, yeah. The Steve Wozniak was like you guys, yeah. But Steve Jobs was thinking about customers, and he was also a geek. And suddenly he thought he was the one of the first guys who thought about the customer, about like to make it simple and just easy. That not like it's the same thing like when you compare the PC and the Macintosh. Yeah, PC is for the geeks, and Macintosh is just for the housewives. Yeah, just for the normal, for the just everyday use, for nothing else. And that's the thing. Like if I need to print something, I don't need to learn. I just go and print. And if it's so easy that that I don't need 4 hours just to start something, but I need only 5 minutes. Okay, you press this button, then you press this button, then you press enter, and then it's starting. Then yes. But if I need 4 hours just for the beginning, I think you guys need to work a little bit more on this of the usefulness and just this accessible thing for the customers. However, now I switch to my subject. Anyway, it's not going to be so much about 3D printing in the beginning, but I'll tell you a little brief insight of who I am and how this whole thing started. Okay. It was a long time ago. It's 1994. It looks very ancient photograph, but actually it's just because it was very bad camera. And the photo paper was very bad, but it looks very old. I like this image because it shows how long time it was. A long time ago. It was only 20 years ago. I started to study sculpture in an art college in Riga, and even then I discovered the problem. The problem was there's a lot of books out there about human body, about anatomy, but they are all written by professors. It's the same problem. Like we have now about 3D printing and CNC technologies, and they all written by professors. And those professors, if you've been in the university, you probably know how it works. When the professor wants to write a book or wants to make a degree, he needs to write this book in a certain language. And this certain academic language requires these very important, complicated words, and these all like not understandable things, And then what the professor does, he makes this huge book, very thick, with black and white pictures, a lot of text about art, about sculpting, about form, and other professors can understand, and they understand each other, and they give him degree, and everybody is happy. And then they print this book for like 150 years, and it's like the table book of any artist. But if you go to the artist and ask, okay, do you really use this book? He says like, yes, I'm using it. How you use it? Okay, I just look at the pictures. So it's just a waste of time, and it's a waste of energy, waste of money. Why then you need to write such a big book with a lot of text? In the end, nobody reads it. Nobody reads it because artists are visualists. They need images, they need pictures. So when you sculpt, you just need an image. You look at the image and then you, okay, it's like this, and then you sculpt. Basically, that's you. Nobody asks artist what he needs, because it's the same thing. Like there's like they are like two separate worlds. And I discovered in 1994, I discovered this problem. So then I had this first idea that maybe I need to write a book about anatomy, but for practical use, not for theoretical use. And the free market changes the whole thing, actually. But in artist world, this free market is not very much, especially in the East Europe, it's not very much developed. Okay, then I finished this academy. First finished college, and I graded academy, and then I did a lot of these kind of things, you know, like hardcore, low-tech sculpting, yeah? It takes a lot of energy, and it's very dangerous, and it's very unhealthy. It's a lot of vibration, a lot of dust, yeah? For technology guys, you guys probably think, okay, it's just fucking low-tech. You don't have to stand there. Just take like CNC machine with a like adjustable, just tip and just cut it. Just stand in distance and just press the button, enter, and it happens. And actually exists. But those two things never meet. The artists and the machinery, they almost never meet. They sometimes meet in like this angle grinder. That's the only technology what reaches us. You know? In the end, of course, there is these huge devices where you put big stone and they cut out the sculpture. This device costs about like 200,000 euros. Just not very big, but just a little one. And nobody, of course, cannot afford it. The problem is why they cannot afford it, because again, the same thing. The technology didn't match the customer. And if technology didn't match the customer, nobody use it. And if nobody use it, then it's expensive. And that's why, because it's expensive, nobody can use it. So it's the same thing with like personal computers and the housewife. They never meet it. They never meet each other unless there is like Steve Jobs who said, okay, housewives, there is a computer for you. And then suddenly, bam! Then we have applications, we have iPhones, we have everything just because of that. Okay, this low-tech era is over. And then I meet guys from the sense sculpting world. I'm going to fast forward these pictures because maybe it's not interesting for you. It's less unhealthy, at least I would say it's more healthy, and it's a lot of fun. It's very quick creating the sculptures, and you can do a lot of stuff in a short period of time, meet a lot of interesting people, improve your language skills and stuff like that, and still sculpt. Of course, it's entertainment sculpture. It's sculpture for the simple people. It's not like the high art, but still, it's a lot of fun. So I spent so many years of doing this. This is how the sand sculptures are built. If you know, maybe I can fast forward these images here. So you pour sand in the boxes, then you compact it, then layer by layer, it's finished, then you drink a beer, and then you start carving. Then you're carving, then you take another layer, you're carving, then you take another layer, you're carving, and then it's done. So it's a sand sculpture complete. And I spent something about 10 years of doing these things, and all the time talking with the sculptors, all the time talking with the people from my business, and hearing his problems. And the problem was always the same. There is a guy with the knowledge, there is a people with who needs that knowledge and who needs technology, and they never meet. And these kind of things, like these seminars, they always make these connections. Okay, little by little, maybe slowly, but it makes these connections. And it's all about like the customer, actually, in the end. And then, what is the next picture? Let's see. Okay, this is from the old time, from the low-tech era, from that time when I was carving clay. Why I showing you this picture? Because it has some connection with the idea of the printing and 3D sculpture. This figure is about like 2.5–3 meters high. There's inside metal frame, and then there's this clay on top of this metal frame. In total, the weight of this figure is about like 200 kilograms, and it has a little tiny connection over here. So basically, you can't release those supporters because it cannot handle this huge weight. And if you need to take a form off, you need it requires a lot of energy. This is me in that time. It requires a lot of energy, a lot of, again, metal frame. It's all so low tech. It takes so much time, and it's in the end you lose so much form. In the end you lose so much detail just because of this so much handwork and heavy machine, like heavy handling the stuff. And now I show you how the artist who has money, how they do in nowadays the same thing. Okay, this is the guy. It's a bronze. In the end, it's casted in a bronze. If you wanna make this modeling from the clay, before you cast it in a gips and then you cast it in a clay again, so many stages. You need a plaster, then you need clay, then you need a wax, then you need a sand form, then you need to cast it again. So it's so many steps just to reach the bronze piece. It would weigh about, I was calculating, it would weigh about like 6 tons. 6 tons. If it's clay. Of course, it's not fully clay. Normally, you put inside some wooden construction, so it makes it release the weight. And man, it's okay. It's not like 6 tons. Okay, it's 1 ton. But still, imagine the 1 ton is standing on these 2 little tiny legs. And this smart guy, he solved the problem a different way. I don't know. Maybe somebody told him how to do it. He made a little sketch this size from the clay. Okay, from the clay. Then he cast it in a gips. Make nice detailing. Then he scanned it. He scanned it all around the way. He scanned it. Then he opened it in a ZBrush or a Mudbox or whatever, any 3D program. Then he cleaned it up. Then he sliced it into slices. And then he milled it out in foam. That's foam. The weight of this head is about like maybe 2 kilograms. Instead of that guy's head would weigh, I don't know, maybe 1 ton. But the difference is 2 kilograms and ton. It's a huge difference. You can take this head and move it to the casting shop and say, okay, can you cast me this head? And the guy say, yes, of course. There's no big tracks, there's no machinery. You can clean it, you can make it nice. So in the end, what he did, he connected all those slices, then he modeled with the wax, not with the clay, he modeled with the wax. Then he cut it again and moved it to the casting shop. And maybe in the end it was 100 kilograms. The whole model, instead of 6 tons, 100 kilograms. It's a big difference. Nowadays, with the 3D printing technology, they print model already from the wax. Basically, they print that, okay, maybe you guys don't know so much about metallurgy, the metal casting thing, but very important thing in a metal casting is thickness of metal. Because depending on thickness of metal, because of this thickness, the cooling down process is different. Basically, just little technology, like this step back. Anyway, if you cast the figure, and if you cast it full, my fingers, they get cool quickly, and they pull bronze from the mass. Basically, it pulls out, it makes big holes everywhere. So fingers, they're cooling down, they're pulling bronze from the big masses, so you have a lot of big holes everywhere. So basically, what you have to do if you want to cast metal, you have to make it like a shell. You have to make it hollow, at least in the big places. And then, as more it goes to the fingers can be full. Basically, in the good old times, there's a huge institutes working on that. They're calculating the thickness of the wax in different places because hand cools down, the parts of the hand cools down quicker than the trunk, for example, and the fingers cools down quicker than for example, the forearm. So. Okay, and now I go back to this guy. So in that time, there's like a guys with a gray beard, with the big glasses, with a lot of knowledge, not so much hairs in the head. They spend like 50, 60 years of just creating these formulas, how to calculate the thicknesses and stuff like that. Nowadays, there is software, and just press the button, and it just prints for you the whole thing. Instead of just like a half year of working on this sculpture, you just work 1 week. And then you just have this whole wax model, then you slice it, and then then it's low-tech. Then you go to the casting shop and say, okay, can you cast it? And then you bring those slices back to the studio, and then you weld it together, and then clean it, and that's it. There's no holes, no loss, all details are there, everybody's happy. Okay, this is the difference. And then me, huh? It's a big jump in world. And probably this bear was created at the same time when I was casting this. Okay, it was later, but still, anyway. It's like living in Africa, seeking for water, where somebody is making the nice gardens and just watering. And it's like I was in Kuwait half year ago, and there was if you in a Middle East country like Kuwait and Persian Bay countries, if you see the green somewhere, anything green, there must be some little pipe go to this plant. This little pipe connected to each plant, and if you see something green, it must be a little pipe connected to the thing. So and there's a desert where there's nothing, and then there's a huge water systems, and then they're making drinking water from the sea by electrics, which is powered by oil, for example. Yeah, and then a few miles further, people are starving and they don't have water at all. So that's those big such contrasts. Like here nowadays, people still have phones with the buttons, and then the people with the smartphones. I don't say that there's difference in the people. There's difference in the phones. It's a big difference in phones. By the way, yesterday there was this iPhone 6 presentation. Probably most of you watched it. I want to share you my feelings about it. So there is no big. I have my iPhone 4S. I would like to buy a new iPhone, but there is no difference. Only difference is price. And I would love to buy. I would love to spend $1,000 for the new device, but it's all the same device. It's all the same device. I don't think maybe this iWatch maybe is a good thing, but I don't think so. Anyway, however, let's go back to the good old times. Okay. Okay. This is the story. This is Art Academy now. This is Latvian Art Academy now. You have these metal huge frames. They spend like 6 years of studying this. 6 years of studying this instead of just studying this. You can, of course, you can model. You don't need to model in clay anymore. And nowadays, if you really want to model physically, you can model without clay, because there's nowadays there's a CX5. It's called clay. It's kind of like artificial material. Of course, it's expensive, but it's future. The thing is, you warm it up, and it's not hot, but it's warm, so you can model. You model, then it gets hard. You can even polish it. It carries its own weight. It's polishable. You can make nice details. And if you want to change something, you just take a torch, the fire, warm it again, and then you remodel it. And if everybody discovers these kind of things, maybe it's even cheaper than to go to the oasis and dig the clay from the ground with the trucks and then load here and then water all the time, water and water. To keep the sculpture moist, you need to water every day for many times, covered with the plastics, and the weight is enormous of the sculpture. So that's the yesterday. And this is the example of the books at that time when I was starting this idea. So this is actually a very good page, because there is pictures. And most of them, they don't have pictures. There's a lot of text describing how to sculpt lips, for example. It's a lot of text and how to sculpt it, or how to not to sculpt. Yeah? With very important, complicated words. And then we had this Kickstarter campaign, and then we released the book. And this is how I explain it. This is how I explain it. It's a very easy way. There is no text at all. And every lunatic can understand how to sculpt the lips. It's very simplified. You have these little parts, and if you understand cylinder, you can understand the lips. We all understand the sphere. We all understand the cylinder. And you just set it up, set it together, and then you have lips. No need to write down how to sculpt. And there's another example about the lips. There's more example with little explanations. Of course, that's still the low tech. That's still the sculpture, anatomical sculptures 01. And by doing this, I discovered that there must be some more, even easier way how to present this idea. Must be, because this grid is not a 3D program. This grid is not the Mudbox or ZBrush or something, or not even the AutoCAD. this grid is Photoshop or Illustrator. That's very low tech, actually, because I've been tortured by this Academy of Arts for many years. Basically I have this processor in my brain. I can put this grid on the picture just by feelings, and I cannot even explain to people how I did it. They ask me how you did it, and I say like, well, I don't know, because I just did it, because they fucking trained me how to do it, and I can do it. But you guys don't have to do it. You don't have to rape your brain to learn how to put the grid on a photograph by pencil. We have 3D programs. You just scan the mouth and the application just puts grid on. But unfortunately, I don't have these 3D sculpting skills. So basically, I went this very old sculpting way. Maybe it's even good for the people. I don't know. Maybe there's not so much people in the business who can understand these technologies, so they can understand me and I can understand them. So maybe there is this thing. I don't know. But I want to go further. I want to develop these technologies. Instead of just making lines with a pencil, I want an application to it for me. And this is how the storage of the plaster models look like in the real world, in academy, in college, anywhere else. So whenever somebody wants to draw something or to learn some form, they go to the storage, switch on the light. There's some spiders. So they take some plastic. Oh, they can't. Oh, can you give me a hand? Okay, we bring it. Oh, and then they bring this guy, putting that. By carrying each time, back and forth, it's cracking, it's breaking, it's getting dirty, and somebody gets some traumas and everything, things like that happen. So in the end, after like 3-4 years, they have to cast it again because it's just wasted, it's broken. And you can't, of course, you can move like a torso or a head, but you cannot move figure. So it's easier just to ask students, okay, let's go to the storage and draw that figure because it's just too heavy. We cannot carry it. And then I went to one of those storages and I just took a few of those heads and I moved to my friend Wilfred Snyder. He lives in Holland, and he had studio and he is geek. He's making 3D printers. He's making CNC machines. He's making scanners. He knows technology. He likes ZBrush. He likes all kinds of technologies. But he's dyslexic. He cannot read, for example, and that's good. Actually, this book is for people like him. He cannot read. He cannot understand numbers. He plays chess very good, by the way, but he cannot, for example, write without mistakes. It's not because he's stupid, but because he has this dyslexic. And actually, even guys don't know how many people in society are dyslexic. It's about like 10 to 20% are dyslexic. And let's say that's a heavily dyslexic people, and then another like 10 to 20% which are like lightly or different way dyslexic. If you know, guys, what is dyslexia? Dyslexia is when you cannot, when your brain cannot really recognize a letter as a letter, but it recognizes, for example, as a piece of art. Or it not all. I have one of my friends when he reads book, his brain is boiling because he has dyslexia and he also has this Asperger syndrome. I don't remember the name. Anyway, Hitler also had it. Anyway, but he developed it in a different way. So basically, the thing is, he sees the letters and he sees the space in between the letters. And brain, the CPU of the brain works double speed, double strength, double power, because it not only the space in between the letters, but it also reads the space in between the lines. It reads everything around and it processing every information. It cannot focus not only on letter. Even if you're just focusing on letter, it's so hard for me. I'm also dyslexic, by the way, not so badly dyslexic as him. But anyway, when I read, I need to read 15 minutes read and then 15 minutes sleep. Then 15 minutes read and 15 minutes sleep. That's the only way how I can read the books. And that's why maybe I succeeded of making book for the retarded in art. Anyway, so we brought this plaster models to for the Wilfred and said, Wilfred, hey, can you help me with this whole fucking thing? Can you make it somehow lighter or smaller or whatever? Then he said, okay, let's see what I can do. He put some marks, then he scanned it. He's scanning with a photo camera. he has some pointer scanner too. He has many kind of devices. Most of those devices not working because he never finished them. He just started to build and he said, no, this device is better. Oh no, I built this device. So he has a studio in a little town in Holland, which is just full of devices. He's just building another, and his wife hates him already. But because he's feeding family, it's okay, you can do it. But still, time to time he buys some nice stuff for the wife. So because when I talk with his wife, she says, okay, he loves CNC better than me. Okay, he sleeps with CNC basically, and I cannot complain because otherwise it's scandal. So we have a second wife is CNC. Okay, today we talk about printer. Then the new love is printer. Basically, he has his second wife CNC, and then he has lover this printer. He bought some industrial printer. So he scanned it, then he processed it and cleaned it up in a ZBrush. And then you see already those little heads over there. Then he printed them. Voila! You can print them hollow, you can print them from plastic. So basically for the drawing you need a big one. Okay, you can print big one, but tiny little one, this big. You don't have to print it like 50 kilos weight. You can print it like 300 grams. You can send it by post to the friend by paying 7 euros in the European Union because it's less than a kilo. For the sculpting, you don't need life size. For sculpting, you need small just to understand the shape. So you could, because it's still better to have and make this thing here instead of with the mouse or with a vacuum. So still holding in hand just give you this another dimension of feeling of the form. So basically, great. I never saw him actually that serious like in this picture. He's laughing all the time. I don't know why he made this face when he was picturing him. However, okay, it's back to the bad old times. Anyway, what I wanted to say, we are launching a Kickstarter campaign in October. I hope so, because I'm going to visit my friend Sanders in Seattle. He lives in America. And basically he was the mastermind behind the project. What we started is Anatomy for Sculptors. I didn't tell you about Anatomy for Sculptors. There's some more pictures actually from the Wilfred. I just show you. This is the good old time how to make just a bottle. Just a very simple bottle. That's the form, that's a bottle. It looks easy, you just cast the kips and it's done. But the bad thing is this form can handle maybe 3 or 4 times of casting. Then after 3 or 4 times you have to make a new form from the bottle what you already casted. So basically it loses every time you remake it. That's for this bottle from the Gibbs. Why people need the bottle from the Gibbs? People need bottle from the Gibbs because when they're drawing they need this shading. That's important. When you paint, the real bottle is not that, but that's what they say. Anyway, this is the low-tech making of the anatomy bones, for example. This guy was just sitting and you see this tools, and then he have book, and then he's creating these bones. You can scan it and just print it. You know how it works. But these guys still earning money. Imagining there's still market for those guys. I hope soon there will no market for them. So this is Wilfred's some of the artworks what he did. This is a sculpture. I don't know the idea, but it's like magnified glass, and there's a skull. But actually, it's all 3D. It's a real model. He's making these things like that. He's experimenting. Then this is another guy from England. Does also very cool stuff. This is Wilfred's some of the. He loves the ZBrush and playing with the ZBrush and stuff. So this is that's Wilfred at work in the sand business. And this is a wall in real life. The wall is 7 meters high. He created from sand this sculpture, and then he scanned it with the iPhone. This is actually scanned with the iPhone 3D object of the wall 7 by 20 meters. And this is also real sand sculpture. You saw him sculpting, and this is 3D model. That he just took the iPhone, walked around, and then put it in. He has some application and put it in a ZBrush, and then he just a little bit play with it, and then he have this 3D model. So you can The idea, every evening after work he comes back to the home and then he plays with these 3D models and then he thinks, oh, maybe I need to add this one, so you can take some pre-made stuff and put in and say, oh no, I don't like it, I just take it out. So basically that's the way how the 3D with the virtual world, and not necessarily replacing it, but making it more rich. This is his stuff. I don't understand these things, but anyway, he likes whatever. This is this sand sculpture in real life. It's in Denmark. It's about 70 meters high and it's more than 20 meters long. That's him smiling. Yeah, now you see him smiling. That's normal him. Then he printed him and his friend. I don't know how he did it, but anyway, he printed in color. He can print in color. He has now 2 printers already. Industrial. Basically, the printers, I don't know if he built them or he bought, but one of those printers he bought, the previous one, the black and white. Now he has a color. Or maybe it's the same printer, I don't know. But I saw the picture, he's working with 2 printers, so probably he has a second one too. This other side of that sculpture, that's him smiling, the sculpture. It's him very happy like a child, holding in hand himself. That's me, huh? That's a big contrast, huh? That's very old sculpture in Switzerland I made like 10 years ago, maybe, I don't know. This is Denmark. It's a huge piece. You cannot print it. It's a lot. It's a lot. This is the bear from the Bronx. That's already done. This is a live scan from the person. There's a guy in England called Chris Ravelsson. He has this company 1024, and he sells the human scans. He's scanning human figures, and he sells it for the gaming industry. And we bought from him some scans for the book. Basically, in my book there's some scans, pictures, because in a scan you can set up the light different way. You can set up the light as it really shows the form. Because when you make a photograph, if you're not a genius photograph, you make these little mistakes with the light. But if you scan it and then you can render it a different way, so you can really see the shapes. Okay, this is back to the future, to the past. However, I finished this idea about October. So, okay, I show you the website first and tell you my dream. Where is this internet thing? Okay, this is a Facebook page. Actually, how I started this book. I started with a Facebook page called Anatomy for Sculptors. Basically, I found another like in the beginning 20,000 poor guys who had the same problems as me. That's how it always works. You find another who has the same idea as you, and then you talk about the problem, and suddenly there's appearing more people who think, and then they found, and then they share, and then they comment, and then you see in Facebook this community grows. So basically it grew to the 20,000. In the beginning I had the idea to make application of the Anatomy for Sculptors application, because it's a 21st century and there's no books anymore needed. It's all applications and stuff like that. So I thought like application, that's the future. And then I built this website, this Facebook page, and this community. And community asked me, okay, before you make application, can you make just book? And I said, why? And they said, yeah, why not? And the friend of mine, okay, and then I thought, okay, I need money to print book. I don't have money. I need at least 20,000. I don't know, 10,000. Actually, I didn't know how many thousands I need, but I need money for the printing. I went to the printing company and I said, like, okay, if I print book, what do I need? Okay, if we print book for you, then you give us your rights. That's what the old printing company does. If they print book for you, they take rights from you. And then I said, what I get? They said, you get maybe some money. I said, like, what kind of money? Maybe 5% of the royalty. I said, but how can I check how many books you sell? You can't check it. So basically, then I can't check it. So okay, forget about book. And then suddenly somebody said, hey, why don't you try Kickstarter? And then I went to online and I checked Kickstarter. Yeah, that's great. And then I filled up the application and I said, sorry, Latvia is not included. You have to be resident of USA or UK. And it's like, again. And then suddenly my friend of mine called him like, hey, I'm in America, I'm just getting a green card, and I'm happy. And I said, oh, green card. And then Kickstarter, green card. Maybe we join together and we build a Kickstarter campaign. And he said like, yes, it's something to do because he's like, a new immigrant in a new country. There's nothing to do, no friends, nothing. He needs some reason to talk about something. He meets new people, and then, who are you? I'm a refugee or something like that, like alien. What else? And then I am the. I'm making book, for example, or I have a company which is dedicated for educate people or something like that. At least you are somebody. And then he meet more and more people. Basically, we launched this campaign, and now we are almost 50,000, and we have a lot of friends and a lot of communication. There's already some pictures of happy people. This is that guy, the Chris Travelson I told you, the guy who is scanning the human bodies and selling them online. And there's a lot of. I'm still posting something. I'm very busy with other stuff, but I'm still posting something. The problem is, I'm the one-man show. That's the problem, because there's nobody who can replace me. If I ask somebody, can you put some good stuff on the internet? When they put something, it's like, oh my god. Maybe you put some. Maybe you don't put anything. Okay, I put something, and then because I have kind of the vision what it has to be, and mostly those images are made by myself. And that's the problem, because I didn't learn to delegate. Yes. I didn't learn how to delegate my stuff I have to do. So if you are interested, you can go. There's like another guys in internet, like in Academy of Lyon. They making 3D animations of the bones and muscles. Actually, very cool stuff. And they funded by French government or something. This is very low tech. This is low tech. This picture is okay. The body is bought from the Shutterstock. This pelvis is stolen from internet somewhere. Then I open it in a Photoshop, and somehow I made this picture. So things like that. This is also very low tech. Just taking like Photoshop and Illustrator and explaining muscles. Actually, if you're not in this field of creating the sculptures or any arts and figurative things, it's not interesting for you. The interesting part for you maybe would be this 3D printing stuff, for example. And the vision is in October we want to launch the campaign, so we start to translate this low-tech 2D book, translate into the 3D. Basically that you have the old book in 3D version. Basically you can see it online. All the objects what I create you can really turn and look from the other side. And the good thing, you can print them out. You can mill them out. That's the thing. And this is the website when I started a long time ago. It's still looking very kind of old. It's not that old. And now we are working on a new website. And the new website, here you can already see. It's website like application. So you open then you see the images and then this is muscles and bones part and the blockouts. And blockouts is a very primitive way, but still people understand. They are very happy. We have something about 1,000 to 2,000 people unique visits a day. This website is visited about like 2,000 people a day looking. Basically, those 2,000 or to 2,000 people, they are people which are using this website like on the second screen when they sculpt. They open it and then they use it. And then suddenly when I hear this, I got this idea, like, wait a minute. If people using my website, like on the second screen, like a tool, maybe I take the old content of the book and put it in the website, straight into the website. I solved two problems. One problem is I solved the stealing problem because we are fighting, because we have this content which people, we have this nice thing called sharing an internet. People are sharing for free stuff when they're hacking and then they're sharing. And if I put everything for free in the internet, this problem is solved. But the question is, where can I get money then? And money I get by providing not the product, but the service. And the service is this website. Basically, you have it on a second screen, very organized images. Whenever you need something, you go online. It's not like you have these folders. Oh, this folder head, eye, anatomy. Oh no, wait a minute. Where was this muscles? No, where did I put those pictures of the figures? Oh, it's there. You know, I'm organizing. They are organized. There's a software, and you can use it on your iPad. You can use it on your phone. You can use it in your screen. And the idea is, and then I share it, and then I make a little. There's a little payment you pay per month or per year, and that makes the whole system running, and everybody's happy. That's my dream. But if we really want to look very 21st century, we need this 3D thing, because this is very low tech. And this October campaign is about that. Basically translating this 3D, this drawings to the 3D, and also making some physical objects, printed objects, so people can order from internet this physical object, not from the plaster, but from plastic, lightweight. So you can email them, sorry, not email, ship them, and they email them. By the way, in the future, it will be like you have this like post office here. Instead of just going to post office, receiving the big block of the stuff, there is a big printer. But not printer you need the 4 hour just introduction, but the printer you really just come, you open your email, then you press enter, and then you step back, and then the product comes out. That's the future. You go to the website, you open the link, you open this, for example, this guy, I click on this guy, and it asks me, maybe you want to buy it. Or I open on my iPhone, and it asks, do you want to buy this guy? Okay, I want to buy it. And then I get message, or what, maybe I don't get even message. I don't get nothing. I just go to the post. I have 2 euros, and I put 2 euros in the box, and then I open my email, click enter, and then the product comes out. No tracks, no ships, no problem. There's just once in a week there's a guy coming with a big package of white powder, pours it in, and then that's it. And the product comes out. And many of products nowadays, what we buy with the money, in America they're trying already to start this idea that you don't need to produce or manufacture and then store them somewhere in the storages. It makes the things very expensive. But if you produce yourself, it makes the thing cheaper, because there's no people who work in production. There's no any like cargo costs, storage costs. There's nothing. And many of products can be printed by printer just like that. The only thing we have to think more of the ease of the customer use. As more we come to the customer, as cheaper technology become. As cheaper technology become, as it more becoming accessible even for the housewives. So that's my story.
Okay, thank you. Questions? Any question?
You mentioned before about that you will tell how you collected your 40,000.
Okay, yeah, how I collected. The main thing is you have to find something what people need and what you can give them for free. That's about the whole marketing of now. The whole marketing of now works. You have to give a lot for free and then take part in a business. Because if you are thinking about like a copyrights all the time and thinking about no, this is I made it and how can I just give it for free? Then forget about the business. If you cannot share for free a lot of stuff and then just take space in the market, if you can't share, forget about the Facebook, because Facebook is very democratic. If people don't like, they just don't like. If they like, they click like. If they like more, they share. And you have to think about that, what you're creating, that they can really use it, that's really useful stuff. If you cannot make something that people really use, ask somebody who can make the stuff. And if you have in a team people who can print, people who can 3D sculpt, and they all are the fans of the 3D sculpting and printing, so they can really make it on very low cost, so they can even give it for free. Because if you need to buy 3D print from the person who can print, it costs you money and it basically demotivating you. But if you can ask the person coming to your team, then together you can build up the community for the 50,000, a million, or 10 million, or billion. The thing is, you have to find something to share what it doesn't ask from you a lot, but it gives a lot. And especially with the electronic, how you say, very smart word, technologies, IT technologies, you can manufacture without costs. Because if you need to print a book, you have to go to the printing house and pay for the printing, for paper, for this, for that, for the storage. So in the end, it's a lot of money, and then you don't want to give it away for free. But if you just share the internet and it doesn't cost you anything, of course you work a lot before creating stuff, but in the end you give it back by the community. Basically, that's the whole trick about the building up communities, is think about what you can give for free. That's the only thing. And now they're paying us. And it's a big difference.
Next question?
Yeah, where can we buy the book?
You can buy it on Amazon, or you can buy it online. We printed it in USA, first edition. Now the second edition is printed here in Latvia since like 2 weeks or something. So now the shipment in Europe became cheap, because before it was enormous. Shipping from USA to Europe. Now we're printing in Latvia. So
it's possible to get it locally here.
Yeah. You can order from, if you buy from the internet, you buy from this American website. But delivery will be Latvian delivery, so basically almost no costs. Yeah, it's Amazon Kindle or what else? iBooks. So you can buy it everywhere now.
Next question? No more questions?
It's also clear, huh? There was some questions from there.
Well, your answer was like another one. Was it hard?
It was fun. Yeah. Basically, it was hard. It's like es latviski pateikšu, tā, kad tagad septembrī es izdomāju rudīties, un es peldēšos, tagad septembrī es peldēšos, un es nāku mājās, es atnāku mājās un bērni prasa, kāds ūdens? Un es saku, atsveicinošs. Principā, mēs sarunājam ar bērniem, ja es saku atsveicinošs, tas nozīmē, ka nenormāli augsts. It was hard, but it was fun. So basically, it pays back. It's like with the kids. It's very hard, but it's fun.
How many sleepless nights?
A lot. Yeah, a lot. It's still going on. And I want to stop this thing, this sleepless nights. I want to stop somehow. But the problem is, I have this little Soviet flat and the kids. So when the kids are on, you cannot. The brain is just off, because when they go to sleep, then you can really start to think, and it's nights usually. Then you wake up in the morning, and then you are like wasted for a while, and then about like noon you start kind of think, your brain starts working, and then of course in the nighttime it works properly.
Yeah. Last question probably.
How fast did you get the response in the Kickstarter project? And who were mainly the sponsors? Just ordinary people or big investors?
It's not sponsors. Kickstarter is not a sponsorship.
Yeah.
It's a pre-ordering. People from the business. Basically, because of this Facebook page, we were able to collect the money. We collected about in a half time needed. So basically, a half period we collected almost the whole sum. But it's a huge psychology actually behind the Kickstarter, because it's not like, okay, I wanna buy this book because I like it. It's not like that. Because psychology changes. The numbers are growing, and people are having different thoughts. There's like we discovered a lot of things behind how people act during the Kickstarter campaign. Actually, the first 3, 4, 5 days is critical. Many people taking out money because they think, oh, they got everything. I don't know. Then later I'll buy from online, but they don't understand. From online, it will be double price. And it was, and people have to pay double price to buy. Basically, we put it very cheap in the Kickstarter. We barely covered the costs, actually, but we made it. And then the price was quite high, because we printed in very small amounts in America and digital printing. Very expensive.
Okay, thank you. So next speaker is Janis.
I'll cut it short.
Yeah.
Maybe Christos can, at the beginning, share some impressions.
Good.
Of London 3D print show because it's generally all about the materials.
Hello everyone, my name is Christos and I went to the 3D show in London that's supposed to be a big deal and was kind of disappointed because I went there to judge other 3D printers on what they manufactured because I'm representing Masportal, and what I saw, that was the disappointing thing. What I saw is not a lot of innovation stuff. I saw something like this, something like that. That's basically MakerBot or Ultimaker, just worse, probably. Then the next thing I kind of liked was stuff like this, Z-Morph or Monofab from Roland. They are 3D printers, lasers, mills into one. So basically you only change the head and some other parts to do a lot of stuff from it. The worst part in this though is that none of them really work good. So you have a lot of stuff, but none of them really have anything good to take out from them. The thing I really liked was these guys from Poland, Pirks. They are building 3D printer now, like any other 3D printer, except they use the little coloring thing from the normal printers to color their object. So when they're printing, they add like black, green, or red to make colorful print. So that was cool. Fortunately, it's not finished yet, but hopefully they will do it soon. And the second thing I really liked and learned in that exhibition was about 3D scanners a little bit. But unfortunately, they have a lot of work and they're all sold out, so didn't have any hands-on experience with them, unable to buy, but hopefully to learn a bit more about them, to include it with Masportal and stuff like that. Basically that's it, kind of disappointing. That was my second exhibition. First was Euromold last year. It's more of a molding exhibition, but there's a huge part of 3D printers now. Also, Masportal is going to participate in one this year, November. So yeah. Oh, and end of September I'm going to TCT, I think. Let me check.
Well, we're checking
TCT show, yeah.
Some things about the London show. Obviously, the show is meant for consumers, and if you don't know anything about 3D printing, it might be worth going there and checking it out. Because you see a lot of trinkets, a lot of interesting little things that will blow your mind for the first time.
The cool dress printed and stuff like that.
But if you really want to go into depth about 3D printing, you should go to the Euromold. There will you see way bigger variety of printers, and then you'll have the chance to see different applications and the printers actually working as they're supposed to work.
And of course, there will be a lot of professionals who is very high level at 3D printing specialists, and that is worth to see what they can do with any kind of methods.
Yeah, it was kind of small too, but I really didn't like the organization of the exhibition. That's why I can't really say. £70. So there's some seminars as well, including from the guy that didn't make it here. But
did you see some kind of trends with the metal 3D printing?
No, not there. There was only.
It's
Or now, maybe you know some kind of
for
trend.
that you have to go to Euromode again.
Yeah. I think Janis will help with strategies. Do they? No? Sorry.
But if
There were a
you
lot
wanna
of-
see metal 3D printers, or if you want to learn more about metal 3D printing and materials that you can print, yeah, Euromode is the place to go.
Oh yeah, you have to check EOS. They are manufacturing, I think.
EOS, Arkham, or there are several little ones that are coming up this year.
For
Most
this
of the
is
low
also
100,000.
metal printing.
Here was only food. Big thing was the pen, the Dodler or whatever it was called. It didn't work. I really wanted to buy it, but it didn't work. So no purchase for me.
About the 3D printing, about the metal 3D printing, I meant basically have some kind of trend that is getting cheaper, that it would be...
Not
it
to
would
my
be-
knowledge.
Yes, because there are some new printers that are going to be announced in Euromode this year. They can be, a start, entry-level metal printers that cost below 100,000 euros. So metal printing is not going to be consumer type of printing ever.
Define cheap now. Or cheap.
Yeah. Cheap. 100,000 euros in metal printing is cheap.
And what?
Because usually the machines that work with high precision and then metal powders, they cost starting 300,000 now.
So that's almost for free.
Okay, thank you. So Janis,
Okay. So actually we are not done discussing exhibitions yet, and a little announcement on my part. I'm not actually in the position to announce it, but I will nevertheless, and it's that this year, shortly before Euromode, like November 15th or 14th, if I'm not mistaken, there's an IT exhibition in Kiipsala, Riga.com, and last year there were Baltic 3D, and we were there, and we, sorry for that, stole the show together, and really our booth were the most busy ones, besides one that gave out free drinks. And this year, of course, they noticed it, and so they have talked to us and to both 3D and to other 3D printing companies, and it could turn out that there's some gathering of 3D printing related and generally 3D stuff related exhibitors in Riga.com. So if you have any business regarding that, 3D printing, 3D scanning, 3D modeling, whatever, you just can ask me for direct contacts, or just go to BT1 website and probably express some interest and refer that I told you. And so that there is probably some 3D printing show in the making. Like this year it's part of Riga.com, but it should grow from somewhere. And so far I see that's the beginning it could grow from. So it's a week before Euromode. And regarding materials, what Peter didn't tell about this London 3D print show and 3D printing in general, by now there's like a race to the bottom regarding printer prices. There's now and then new Chinese and different printers coming out for $300 and less, and the innovation is mostly like how to make a printer cheaper these days, and the other trend is in the materials, and that's far more interesting because the printers are now somehow you can like buy a Ultimaker or Mass Portal or MakerBot or any other good printer, and it's more or less predictable, and you know what it's gonna do and how it works and so on, but it's all about materials that matter. And we have this default PLA, ABS and other stuff, but there's now, only now, like 5 years after the MakerBot came on the scene, there some recognizable names appeared from the chemical industry and from guys who really know something about plastics. And up till now, it was all small startups, like 5 guys in Texas or somewhere 7 guys in the Netherlands, and it was all like startups who could recall from floppy disks and CD-ROMs. Mitsubishi Chemical and the remains of Kodak, Eastman Chemical, like some big names in the chemical business are slowly and experimentally entering this. Besides that, there are tons of startups popping up and introducing new 3D printing materials, basically every minute. So by the time I finish this presentation, it will be already obsolete. There will be.
But I think those little startups are swallowed by those big companies. Basically, it's the 7 guys from Netherlands are bought from the big chemical companies and stuff.
Not yet, at least what I see.
Yeah, but I think that's the way how they starting the new technology, because they, besides the guys who knows chemistry, they also need some people who know something about the printing. So basically, they need to buy little companies from Netherlands just to start this subject.
And we have had talks with like Latvian chemical companies here. The same stuff.
Latvian chemical companies.
The same stuff. They are interested.
Sounds boring already.
No, it's actually not, because there was. I'm not that old, but there was a lot of military industry and very high precision industry in Latvia. That's now mostly gone, but there are still these guys who did it over here, and they can tell a lot about like precision plastics, extrusion and stuff like that. That's very important for 3D printing, and it's on the screen. Maybe not as visible as I wanted to, but it's like the same material from the same manufacturer, and just different colors, and you see there's a lot of difference. This is taking into account that the model, the printing regimes, and everything is the same. So you can get very different results with the materials now. And I will cut this presentation short, and I will not go into the details like temperatures and stuff like that. That's going to be discussed over there in that room. But what we figured out selling some printers to clients, and so that everybody is kind of like experimenting only in the beginning, then it's like freezing. This works for me, it doesn't, and then it stops. And of course, we are like in a different position, so we experiment a lot, and I would want to have this presentation as an encouragement to go on and still try out these new materials and share the stuff for free on Facebook, whatever, what works, what does not, because you can't really trust the reviews or something. You have to check it out, and also our experience is that like this is a sample of mother of all hell with 3D printing. Like you buy expensive filament rolls from reputable sources, and this happens. This is not common, but it happens, and it's cool if you notice it. If not, you get like failed print or something, and that's the stuff that nobody like wants to share on the internet, and it's okay. It shouldn't be shared. But then this is the first thing you have to look for in the printing materials. Don't go for the cheap ones. Just don't do it. If you have time for something else, do something else, and go for the best materials you can find. And they are not necessarily the most expensive ones, but we have had this and different unpleasant surprises from the very, very best of the material vendors. So like 2 rolls of the same material, the same color, they're completely different colors in real world. So that shows that all this material industry is on the same page, like with the printers, that it's still very experimental and nowhere near where this housewife can and click and go. So there's really a lot of hope that the big chemical names will change it and introduce some next level of quality. And I'm not gonna name any brand names or something. There are very good material options, but I already repeat that we have probably wasted more roles than I think anybody else in this room just playing with stuff and not as purposefully or productively or but so we have some hands-on experience, and even the best brand names on the market have these kinds of PLA. Still the default printing material and useful one for stuff like that, and generally for printing out forms, prints pretty easily, has nasty surprises because it's acid, it's polylactic acid, and it's printed at 200 degrees. So just imagine not just boiling acid, but boiling acid at 200 degrees, and that's the stuff. Still, it's healthy quite, and it's made from corn fat or palm fat, and just the default printing material. It's biodegradable. It's not meant to be recycled. You just throw it out. So the default choice for printing, and I know I see some guys in this room that are very experienced, far more experienced than I am. And I just want to add that lots of PLA-based materials are coming out, named with every imaginable name, and not mentioning the PLA stuff because it tends to cause some issues with the printing now and then. And maybe the worst part about this material, it's not very durable, like in outside and outdoors. It will degrade in sunlight and do it very rapidly, as it's bioplastic. And it's at 50, 60 degrees, namely in a hot car in a summer day, it's gonna melt. It's gonna totally lose its form, and if you send like printed parts somewhere over in mail that's gonna be air-shipped or whatever, it can easily in the plane reach that temperature, especially if sent to Australia or some other hot country. So your print can arrive not the way you intend it to be. And that's especially a problem if you are sending out like precision or something like that. So PLA, good for everything, but not really good for things. Yes, still the prototyping material of choice, mostly because it's the same stuff that goes into molding. There are some modifications of ABS later on, but it's a bit smelly when it prints. It's poisonous. It's oil-based, so oil's not good. You know what like happened to that.
Not print with ABS when you are pregnant.
Yeah. If you're gonna print it like through the night and check how it goes all the time in the high by morning, I've been. It's good for stuff like this picture, like for devices, for parts that are going to be used. It's pretty. It's not hard, like it's a bit plastic, but it's the stuff that like Lego bricks or vacuum cleaner cases are made of. So it's an industrial plastic, all based, recyclable, and very easy to post-process. An example of post-processed ABS printout I already showed last time, and the tools that are most important is like this. Just a little post-processing, and prints are big money. Look that not even the most expensive $100,000 printers on the market can match it yet. The finish is obtained with just post-processing, painting, polishing. It's not going to come out from any 3D printer on the market at any price. So dangerous technology, just plain desktop printer and some fiddling around with just regular old school stuff and like nail polishes, it's called. And bad thing about ABS, it can go wrong, it will go wrong. This is human error, but it shows an example. It bends when printed. It needs to be cooled down slowly. It needs printer with an enclosed build chamber and needs heated bed, so it's a bit more tricky to print than PLA. We learned from a customer that there's good ABS and there's bad ABS. We have had good results with bad ABS as well, but this is an example of an ABS that has air bubbles in it. You just bend it, it shows. We didn't know it before, but now we do. And so there's some variation of ABS that's mixed with polycarbonate, sold for twice the money, or at least far more expensive. But it's always check out whether you can get this. All these smart ABS, Z ABS and whatnot, they are just ABS and polycarbonate mixed, and a bit more difficult to get information how to do about it, but it's more sturdy and tends to work less. And we, in the real life, we probably didn't see a real reason to go for it from our perspective, but it works less. It works really less than proper ABS. So for a lot of prototyping, it might be not so good because it's more expensive for the real. Otherwise, flexible materials. Now everybody wants to do it, and it's really useful for medicine, for printing. You can sell a kidney, not your real one, but a 3D printed one, and you will buy some more filament. And this is like phantom organ that's going to be used to train students to make injections. So it's flexible. It's like the real size and more easy to obtain than on the black market. Another example of flexible material, nylon. It's really tough. It's probably the toughest material right now on the FDM printed market, and there are lots of nylon-based materials now coming out. Some of them very interesting, like reinforced with nanotubes with carbon fiber, and in some cases this material is more durable, more sturdy than aluminum. And you can check it out. I have it with me later. It's the real thing. So really useful in PET is another coming up material that could probably be as widely used someday as PLA, because it's there's a lot of PET out there, as you know, Coca-Cola bottles and stuff like that, and it can be from transparent to very opaque, and it's very good colors. And contrary to what's written on the web, it does work when printing. So it needs to be printed kind of slowly, but you can get very good results. It's also very sturdy. When printed like in solid objects, it's very hard, very good edge and surface quality. So it's a bit more expensive than PLA, or easily it could be twice as expensive as ABS right now, but it's a very interesting choice. We don't know how how to process it afterwards. Yes, nylon is the tough stuff you print when you want to have something that's unbreakable, and it's hard to print in large objects. It works even more than ABS, but it's very tough. You can print some gears, and it has very different. There are different kinds of nylons, and there are some companies now popping up. You can buy nylon in color that you couldn't like half a year ago, and you can print really stuff that's tougher than like original part you are replacing. For example, some gears in some stereo equipment or something, in old printers, or if you want to repair some laboratory device, there could like be some plastic part in it that you are printing a replacement in nylon. It will be far more sturdy and durable than the original one. So it's a really interesting material going on. And this is it's also flexible if it's thin, but if it's not thin, it's not flexible anymore. It's very hard. And it's like Rupal said, by now it's the only material from these desktop class printers that's indestructible. You can't separate it the layer by layer. You have to like take a knife or something if it's properly printed. Then you can color it. This is what happens when you print nylon on the wrong surface. It doesn't stick too well to very smooth surfaces, and it works. So it's tricky to print, but it's really advanced. If you got to get it sticking, you need a bit of roughness to the surface, and that's not a discussion of this presentation. But then there are lots of imitation materials coming out in this stage. Most of them PLA based, and silver, bronze, the most well-known are the wood imitation. This is how it looks and smells like wood. It really does. And sandstone or the concrete imitation. And these are not these pictures. These are not our prints, because the rest were. And now also some new materials like structure and feel of linen and satin. So all over the place, bronze, gold, whatever, looking really nice. Most of them PLA based. Print totally not like PLA. They are all over the place. Some print in completely different settings, but still most of them are PLA based. So not very durable, not very useful stuff other than checking out the forms. And some worth mentioning, like is PS. That's the material foam in cardboard boxes is made from, and in this case it's very easy to print, and we were referred to it for reasons that it has like a paper-like surface that's easy to write on. Could be useful in medicine when you print out again like bones or something that need to somehow have some doctors writing something on it, and even easier to post-process than ABS, although the physical properties are not that good. It's not that sturdy and not that hard. And regarding this polystyrene, the most interesting thing about it that I'm not covering today is printing with dual extruders and using these support materials. Up to now, it's usually done with PVA and ABS, and as far as some guys I know that want to try it, but this is a common knowledge that it's not working very well. And the new thing is printing ABS together with polystyrene. There's a solvent that dissolves polystyrene and does not dissolve ABS. And they print at about the same print settings, so they are mix and match. So if you have not tried or thrown out your dual extruder printer set, this is the way to go, probably, and not, or at least to experiment with. And, so, just a short reminder to experiment. It's not like well-known science yet. There's no books written on 3D printing materials that are any good, because it changes every day, and by the time you read the book, it's already obsolete. And so that was my.
Okay, thank you. So, questions for Janis for materials, printers.
What about polycarbonate?
Polycarbonate, it's more. I didn't cover industrial plastics that are more than like 270 or something degrees to print. There's a whole lot of them, but they are kind of different to get. You have limited color options, and basically it's useful for engineering purposes, if like to check molds or stuff like that, or to print again tough parts. PP, like polypropylene, useful for food stuff. It's just as PET. It's very chemically resistant. But there are issues with the polycarbonate, with the polypropylene, and other materials. As they are all popping up now, but these are the general ones that tend to stick to either the Kapton or the paper tape that's generally used to cover the print bed. And for example, the polypropylene will not stick to anything but to itself or to some solvent. Again, and so just matter of experimenting. If you have a roll of polycarbonate, I think we do, but we haven't tried it yet. So,
Yeah, please.
Can food be printed?
sorry,
Food.
food.
Organic food. I read that.
Yeah, I also read that there's a printed Big Mac, but it didn't taste so well. So
What materials do they use?
no, the real stuff. They somehow printed some meat and everything. There was like a science project, a big money project, and but I read that it was
different. It was laboratory grown from cells.
maybe that's a different one, because at least I know that sugar, it's sugar and chocolate. It's common thing.
Janis, I think PLA can be eaten. Or not.
For the fact.
Question. Print from tin.
From
Tin.
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 There's stuff about this. One thing about this thermoplastic printers, or FDM, or basically filament-based printers that are using thermoplastics, is that they can't really print with metals that melt at low temperatures. Although the printhead is capable of that, but you need to have this state between hard and liquid. That's property of thermoplastics, and the metals don't have it. They are either they become softer with temperature, but then at one point they are just liquid, and you need to have this viscous state in between that's used that's the basis for this fused filament like printing. And it's again a matter of experimenting, but as far as I know, there have been attempts to print with low temperature metals, but with technology like this, but it didn't work. At least I don't know of any successful like modifications or.
Any more questions?
If there are more like specific questions about materials, then you can ask other guys over there with real examples and more experience than me. I'm just.
So what kind of equipment we have today?
There's some printers you can check out, and there are also some samples of printed materials, and one from a bit more expensive printer. There's like a human figurine. It's a bit damaged, but it's printed from paper. There's this Encore United Kingdom company that's either the only ones or one of the guys who are making paper-based 3D printers. You can check out the print.
They are last ones.
Or the last ones. It's kind of exotic. And regarding human printing, I can probably share that in Tallinn this week probably I've been there last week and I'm going again on Friday, so I'll double check. But there's some customers of ours, they have built a 3D scanner themselves that consists of like 50 SLR cameras, and you just walk in, no turning around, no waiting. It's like in a photo studio, it's like quick and you...
That's exactly how this Kickstarter starts.
Yeah, one flash, and it's in the very downtown Tallinn city center, and by now they have only the scanner. They can make a scan of you, a figurine, process it and send it over to Shapeface to print, but they are gonna have like a color powder-based expensive $100,000 printer. I think in January, so probably if they are doing good in Tallinn, they'll also come to Jurmala or some other places where there's a market for like wedding souvenirs or stuff, but it's the nearest. If you happen to be there, go check it out. It's very impressive. You can just like take a picture, cheese, and there you are in full color. All your clothes, very high resolution 3D scan all instantly. And
Where is this place?
you can. It's going to change the name because they moved in the previous week. And now you can find them by Wolfprint. Anyway, I'll share the location later on.
Okay. Thank you. Any more questions for the audience? Okay, that's it. Thank you.
Okay.
Yeah. So.
Thanks.
So this was last video for today. So anybody have some kind of application short for anything